Well, hi everyone. I've got a very interesting video for you today that involves an apparent geotechnical failure for both abutments of a bridge under construction in the Yukon Territory of Canada. In fact, this bridge is the largest construction project ever in the history of the Yukon Territory. So, quite interesting. And we're talking about Nisutlin Bay in Canada, in the Yukon Territory. You can see in this photo the adjacent existing bridge that's still open to traffic that was constructed from 1953 to 1956. And the new bridge is in place, but there's been some alarming movement of the abutments. Appears to be a global slope stability issue. And I'm going to go through the details of the information that we have, as well as the few tidbits that the Yukon government has released about this situation. It's a beautiful area. This existing bridge was constructed from 1953 to 1956 across the bay. And the existing bridge is a through truss bridge with 7 spans. See this photo here, the existing bridge off to the left. The original timber bridge that was constructed as part of the Alaskan Highway, constructed in 1942, was adjacent to that bridge, you can see in the photo. And I'm going to cover this in a separate video because this is a monumental engineering feat, the construction of the Alaskan Highway. In an 8-month period from 1941 to 1942 is obviously wartime construction. The U.S. government footed the bill, and then in 1946, the Canadian government took responsibility for all the bridges and roadways in their country. So again, tremendous feat. The Alaskan Highway involved 27,000 workers, 11,000 of them were U.S. troops, over 7,000 pieces of heavy equipment, over 133 bridges were constructed. And this bridge over Nisutlin Bay was the longest span over water along the Alaskan Highway, still is. And this truss bridge that's being replaced was 1,917 feet long, which involved a 400-foot reduction in the overall length of the bridge compared to the old timber bridge. Let's just run some footage here from CBC. This shows the new bridge under construction adjacent to the old truss bridge. Quite a scenic area. Very difficult circumstances to construct a bridge this far north. I imagine their construction season is probably only about 3 months long, possibly 4 months at most. On April 1st, 2026, the Minister of Highways and Public Works of Yukon Territory issued this press release stating that the government of Yukon is engaging a new engineer to oversee the Nisutlin Bay Bridge project to ensure the bridge is completed safely, efficiently, and in the best interest of taxpayers. Concerns were raised in summer of 2025 about soil conditions near the north and south abutments of the new bridge, resulting in the need for remediation work at both locations. Since then, the government has consulted with various experts to develop a permanent remediation solution. So they allocated funding for the project back in 2019. The work actually started in 2022 and was scheduled to be completed in March of 2026. So a little over 3 years, which is a longer time period than the current truss bridge took to build from 1953 to 1956. And of course, now they've got problems with the new bridge, and it's going to be additional money. Obviously, they've spent $160 million originally for this bridge. With various cost overruns, they're at $180 million now. And I suspect that they could be looking at tens of millions of more dollars and months, if not years, of additional delays before this bridge is open. Now, I reached out to a spokesperson for Yukon Territories, and they were kind enough to get back to me. That's not always the case with these DOT or transportation officials. And they sent me a link to a couple of press releases and a frequently asked questions site. So the information was, again, it was rather polite, but very vague. But we're going to drill down and see what we can figure out here. Now, the prime contractor is this Canadian company from Alberta, Graham. And if you go to their website, they show almost exclusively commercial building construction. I'm sure they're experienced at bridge work. At least that's what my Google search indicated, but they're not really touting it so much on their website, it seems. And they had a statement at the onset of the project talking about the importance of having good relations with the indigenous groups there, an environmentally sustainable bridge, which I don't know what that means unless it has to do with paint selection. I I honestly don't know what an environmentally sustainable bridge is. So maybe that'll be a topic for a future video. And then WSP is cited as being their design engineer for this project, a large Canadian civil engineering company. And we've got this other statement, this other press release. This is May 5th, 2026. I'm recording this video on May 21st, 2026. Further to the April 1st statement, which I just summarized for you, the Nisutlin Bay Bridge Replacement Project, Yukon government is continuing to work to advance the project to its next phase, focus on finalizing a long-term remediation solution and preparing for construction to resume. As part of this transition, the government of Yukon and Graham Infrastructure LP, the project's lead contractor, have mutually agreed to end the current construction contract. This decision supports a cost-effective path forward while reducing the risks of delays or additional expenses. And that's about as polite as you can put it when you say you're kicking your contractor off because there's something that's screwed up on the project, apparently. The remediation design will be completed in the coming months, after which the remaining construction will be re-tendered. Well, the coming months is going to put them out of this year's construction season, I would think. And as I mentioned, I got this frequently asked questions document, and this is about as low key as you can state a major bridge project problem. Last summer, experts identified some concerns with the soil conditions near the bridge supports. A new engineer will be engaged to provide expertise and oversee the remaining work on the project, including soil remediation work. The term soil remediation here refers to addressing these natural soil conditions. It does not mean the soil is contaminated and no hazardous material cleanup is needed. And they say, in the meantime, the current bridge is safe for operation. Now, here's the project location near the town of Teslin, Yukon Territory. And this is from Google Earth. You can see they've got the work trestle, you have the existing bridge, and they're building the new bridge. And I just did a quick measurement here, and the overall length's about 1,840 feet. And this is a photo of what the bridge looked like prior to this recent construction. So let's just go through the construction sequencing real quick. The contract was awarded in spring 2022. They started work in the fall of 2022 with site prep and some other construction activity. Fall of 2023, you can see they're working on the work trestle into fall of 2024, as well as construction of the foundations and the abutments in 2024. And a lot of the bridge structure was completed in the fall of 2025. Now, I found this very interesting technical source that was produced by some engineers with Parsons Incorporated. And this is the most information I could find relative to the technical aspects of this bridge project. Apparently, this construction was utilizing what's called accelerated bridge construction methods, ABC. And the idea was to try and shorten the amount of construction activity to fit in with the available short construction season, even though the planned construction period was longer than the original construction period. But these days, of course, there are a lot more environmental constraints and permitting constraints. I don't know all the details that went into their construction schedule, but clearly they haven't met that now, though, since the bridge is not open. So our clues as to what's the problem with this bridge has to do with the abutments that was mentioned in the press releases. And this Parsons paper talks about a conventional abutment with bearings, and then you have an integral abutment. So I suspect the original construction was more conventional. You see you have a different connection detail here from the approach slab to the bridge itself. And now you have what is part of this accelerated bridge construction detail with an isolated abutment. And you can see you have mechanically stabilized earth wall. So you have these reinforcing strips made of aluminum or geosynthetic grids, and they're layered as you place the backfill for this MSE wall. And you have what's called a jump slab to go from the abutment to your first bridge column. And the information I have is that the deep foundations at the pier locations consist of either 24-inch or 36-inch diameter pipe pile. Again, I don't have these details, but obviously some type of deep foundation. The soils in this area aren't very strong in terms of the ability to support large structures, heavy structures like a bridge without utilizing a deep foundation. And I understand that these piling are probably on the order of around 100 feet or more in depth. But reading between the lines, they've got a problem with global stability. So it appears that the abutment is sliding, and that massive sliding material may be impacting the foundations for the bridge pier. Again, this is an inference I've made from the available information. I think Yukon Territory officials ought to be a little more forthcoming about what's going on here. Now, I understand not everyone's interested in the technical details, but I think they could go clearly beyond what they've stated so far. But they've got a big mess on their hands if they're looking at any issues with global stability. These deep foundations are designed primarily to support the axial loads as well as some lateral loads from the dynamic loading of bridge traffic. But typically, these foundations aren't designed to withstand loading from a mass of sliding soil. That's a special application, a special design for deep foundations. And just to me, that if they've got a problem with the abutment, they could have some impacts with the actual bridge pier as well. As I mentioned, this is a very interesting area. Apparently, this is an area that is inhabited by many individuals from Tlingit tribal group. Coincidence would have it, I go to a medical provider where there's a lot of donated art from various patrons and patients. And my favorite artist was a Tlingit artist from the Pacific Northwest, an artist named Preston Singletary. So I've got a link to all these references in the description to this video if you want to check it out. But what really strikes me is that here you have a bridge that was built originally in 1942, the Timber Bridge, and was in service for well over a decade. And then you have the new bridge, the current truss bridge, I say. It was constructed in 1953 to 1956 and was in service for 70 years, still is, without any apparent issues. And then you have modern day design and construction, and you have massive problems. And typically, when you have problems like this, it's usually an unknown about the subsurface, some condition that was encountered that you didn't anticipate. But you can't really use that excuse here, I don't think, because it's right next to an existing bridge. I mean, it's highly unlikely that you have one set of conditions that permitted the design and construction of a bridge successfully for over 70 years, and then right next to it, you have conditions that caused a problem that weren't anticipated. Obviously, you're going to do additional geotechnical borings for the new construction and the design. You're not going to rely on old borings from the 1950s. So it just is bothersome to me that it just seems from a superficial level that there's some variable here that unduly complicates modern construction. It drags it out. There's usually litigation, and it's very hard to learn what may have happened here so that these lessons could be applied to future projects. Again, this accelerated bridge construction seems to be more and more in use on various projects throughout the world. And I think something fundamentally wrong has happened here, whether it was something with the construction sequencing, some design error, some issue with the subsurface conditions. But the problem is once you have global sliding of a large mass of material, if in fact that's what is going on here, which I believe is the case, you tend to reduce soil strengths to a very low value. And you have soil strengths much lower than you would have had the mass of soil never moved in the first place. This results in a huge complication where they might have to do soil nailing or other remediation measures, specialty geotechnical construction. Worst case scenario, they've got to dig out the abutments and start all over. I hope that's not the case. But again, I would call on the Yukon government to let the public know exactly what's going on here. And still they can preserve their options with any legal matters, if applicable, with the construction contractor and the design engineer. So I'll continue to follow this story. If you're local to this area, please email me. This is my email address. If you're able to take photos or even drone footage would be fantastic. Please send it to me because I want to follow up with this story. And given the remote nature of this project and the reluctance of the Yukon government to really provide a lot of details, I'd like to really crowdsource the investigation of what's going on here, at least from a public perspective. So with that, I'd like to send a shout out to those of you who have contributed to Buy Me a Coffee. That's one of the better ways to support this channel. I also want to thank the channel members and those of you who've contributed to Super Thanks, additional great ways to support the channel. So stay tuned for future videos, everyone.